Okay, so we basically have the differential equation. Just a second. अच्छा आ गया. Okay. So differential equations. Okay. I'll. So अच्छा जी देखो भाई, this chapter also required all of like the calculus thing that you guys studied in integration and alongside with the partial fraction. Okay, so these two things are very important for this chapter. Okay, the first one is okay, basically the first one is the partial fraction. Okay, and the second is the integration and all type of the integration. Okay, okay, so these are basically the two chapters with which the differential equation um, is connected, or basically it's all the integration, right? Differential equation is basically all the integration, right? So, but the question pattern or the question type or the trick is slightly different from the integration, right? In integration, they directly give mention some sort of equation and they ask you to integrate it, okay? And you have to see which method you have to use, or you have to check which function it has, and according to that, you have to differentiate, integrate it, right? But in the differential equation, it's slightly different from like that concept, right? So basically, in like the differential equation is very much into our like daily life. Like you can take the water flow in and out as why. So basically, yep, you can take the water flow rate and you can make the differential equation out of it, right? Like you're filling some sort of cane or some sort of jug with water, and you know that the water is coming out of the tap or out of the point with this much flow rate, and you can just make the equation differential equation in term of time, that how long will or how long the jug takes to fully fill if the water flow at this rate, right? So this type of things are basically required the deep understanding of the differential equation. If you have to formulate anything, or if you have to make any function into the equation, right? Or anything into the equation, so we use the differential equations, right? So it could be like related to anything, right? So yeah, and uh, 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 okay, so in like for the with respect to paper, um differential. Okay, so as far as the paper is concerned, you can say, Acha, by the way, you can expect like 10 mark question, approximately 10 mark question. Okay, and it is नहीं 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 वो सब नहीं चाहिए. Generally वो सब नहीं चाहिए. Generally normal differentiation चाहिए, normal integration basically. सही. So Why from the next week or from the next classes or from this classes, kindly make sure to attend all the classes, right? Because in the next week probably I'll be starting yearlies, and we have very short time. Okay, so be available in the class. Okay, बेटा ये जो इंशाल्लाह की टोपी दे रहे हो ना तुम, इंसान में जो, अच्छा जी. So if we have like the differential equation with respect to paper, we can say that any equation that has dy over dx, term given, any equation that um, that makes it, that is written in term of dy by dx, right? And the question, yep. So this is basically the simple form of like the paper related thing, not in general, right? In general, we say that any equation or any physical thing that you want to write it in the mathematics form, right? Anything that is changing and you want to write that change into mathematical form is the differential equation, right? If I define to write the um, physical thing that is changing into in mathematics, okay, in mathematics, okay, like if you remember the charging and discharging of the capacitor, right? So the equation that we use is basically the differential equation, and out of that differential equation, when you solve it, you will end up getting that equation: c is equals to c naught e power minus t upon tau, or तुम कह लो और q या v ले लो. So v is equals to v naught minus t upon tau, right? So yeah, or if you remember the radioactivity, right? So in that we have the equation n is equals to n naught e power minus lambda t, right? So these type of equation are basically uh when you have like when you make the differential equation of the decay or of the discharging, and then when you simplify it or solve it, right? So you will end up getting these sort of equations, right? And they are like the physical thing or the physical scenario, like if you have any sort of like decay going on, so this is a physical scenario. If you have the discharging going on, so that is a physical scenario, and you are basically converting it into mathematical equation, right? And in paper, generally in the question they give you any equation, they give like they give the question with with the equation starting with dy by dx, right? So this is what it means. अच्छा जी. नहीं ना, डिफरेंशिएशन में they ask you to find the dy by dx, right? मतलब in the differentiation they mention the equation and they ask you to find dy by dx, but in the differential equation they give any equation in term of dy by dx, and you have to solve it back to the equation, right? This is what you used to do in integration basically, and yep, this is also an integration, so yes. Okay, now since this chapter is like all about the integration, so there's nothing to teach. It is just we have to go through the question type right away. So type of the questions. Come on. You can expect three type of question from this chapter, and generally there. very easy. If you have a good grip in integration, then you will find this chapter very easy. Okay. The first type of the question is where they mention the scenario and they give you the equation. See, so given equation. Okay. And the second type of the scenario is the word problem. Okay, where they mention the scenario and they ask you to find out the equation. Okay, or to drive the equation, right, or not to drive the equation. Basically, they mention everything in words and you have to convert it into equation, right? So word problem. And the third type of the scenario is where you have to drive the equation, right? They give you the scenario and they ask you about it, right? And you have to form the equation, right? And there's a slight difference between the word problem and the other thing. In the word problem, they mention every part of the equation, and you just have to put it into the form of equation, right? And in that part, in the driving the equation form, they mention the scenario physically, and you have to convert it into mathematics, right? So drive the drive the um, uh, mathematical equation, mathematical equation of any physical, come on, any physical scenario or setup, right? These are basically the three things or the three type of the question that you can expect. Okay, and inside those three questions, how to solve those type of question, let's go into that. Okay, so type 1, type 1 differential equation. Differential equation. Okay, so यहाँ पे मेरा n रहा हुआ है. सही हो गया. Okay, so now, okay, so this is the type 1 question, okay, where they're saying in a certain chemical reaction, the amount X in gram of the substance is decreasing. Okay, this could be the reactant. The differential equation relating X and T, the time in seconds since the reaction started, is this. Okay, so the differential equation is given in the form of dx and dt. Okay, and this is the equation, right? Now they're saying K, the positive constant, is given that X is 100 at the start of the reaction. Fine. So solve the differential equation and obtaining the relationship between x and t and x, t, and k, right? So what you have to solve, or how you have to solve is you just need to follow 3 or 4 steps. Okay. So they are basically as follow. Okay. So you first have to separate the y and like the dx and the dt and their corresponding variable. Okay. So this is the first step that you have to do, and that is to separate the dx and x together. So dx and x one and puts at one side, and k x and sorry, k t and dt on the other side, right? So this is the first step that you have to do, right? To separate the variables, okay, and to separate the dx and dt, and both should be in the numerator. Dx or dt should not be in the denominator. Okay, so this is the first step. Okay, I will write every step at the end of the question. Okay, don't worry. So this is the first step, and then the second step is to integrate both side. Okay, k is a constant, so you can ignore the k, or you can take the k outside, right? And okay, so integrated, when you integrate, you apply the limits. Okay, so but for now you don't have to use the limit because we are converting into the equation or expression, right? So do you guys can you guys tell me what is the integration of 1 over x dx? Yes.
ln x,
Sorry.
ln x,
Okay, good. And what about under root t? That is ln x plus is equals to negative k. Yes, and what about the under root t? Under root is basically negative 1 over 2, just right. And for integration, you the power would be 3 over 2 and divided by the new power, which would
divided by
be
3 over
3
2.
over 2. So I can write 2 over 3, right? After getting reciprocal. Okay, plus c. Okay, you can add the c at any of the side. Okay, it could be there or it could be there, right? Generally, if you look at the concept of the integration, so we have to add the constant at both sides, right? See here and see here as well, right? And but when you take it to the other side, so that becomes c1 minus c2 or c2 minus c1, so that would again be a constant. So you can just put the constant at any one side. Okay, so this is the integration you have, right? Now you have to simplify, you have to find out the value of c and k as well, right? So let's try to find out the value of c and k. Okay, chalo आओ. Okay, so we know that x is okay, it is given that x at the start of the reaction t would be 0, right? So there's one thing given, so I can put ln 100. Okay, when t is 0, so I'll get c from this point, right? Clear? So when x is 100 and t is 0, and I put that into the equation, so I end up getting this thing, right? Now moving on, I know my c, and can I find out, okay, in term of k I want, so it would just be um, ln x is equals to minus 2 over 3 k t, and then plus ln c, ln 100, right? But okay, so this is one form of the equation, or this would be like done. Okay, this is what the answer. Okay, so this is the first part. Now the second part is, given that t is 25 and x is 80, find the value of t when x is 40, right? So you can use the first value to find out the k, and the second value of x to find out its corresponding value of t, right? So let's use t equals to 25, okay, when x is 80, and solve it. So ln 80 minus is equals to minus 2 over 3, and then k is to be found, t is 25 plus ln 100. Okay, so when you
Uh,
solve, right?
it's 25 to the into 3 raised to 3 over 2.
Oh yes. Oh, 3 over 2. Okay, so that would be 125. Okay, so ln 80 minus ln 100, or basically ln 80 over 100, so would be ln 0.8, right? So ln 0.8, okay, is equals to under root 25 would be 5, and cube root 5 is 125, and so it would be 250 over 3 and k with a negative sign. Okay, so 3 ln of 0.8 over 250 with a negative sign is the value of k, right? You can find it in like the numerical form. And now uh, now you have to find out the value of t when x is 40. Okay, so let's just put x as 40. Okay, is equals to negative 2 over 3k. Okay, and t is to be found. Okay, plus ln 100, right? And you can solve it, right? You know the value of k, just find out the value of k and put it in. Okay, so from this side you will get ln 40 divided by 100, so ln 0.4. Okay, times it by 3 over 2k, and yes, is equals to t 3 over 2, right? So we can solve it and you'll get the value. So when you solve minus 3 ln point 0.8 point 0.8 divided by 250, you will get 2.67 exponent negative 3, right? And now you can put that back into the equation, ln point 0.4, okay, into 3 divided by 2 into answer, and it is equals to this. Is it, by the way, ln 80? Okay, fine, that's correct. 0.83 and 150. Okay, so 250 over 3. So 3 ln 250k, that's fine. And ln point 0.4 and 3. Why I am getting it in negative? 2.67 exponent negative 3. Okay. There should also be the negative sign, yes. Okay. So, okay. So I am getting 513.8. Okay. So if you do a square 513.18, and you have raised it to the power of 2 over 3. So I'm getting 64. Okay. So T is 64, right? Do you guys get it? जरा कुछ रिएक्शन दे दो प्लीज.
Yeah.
ओके, आशिर समझ रहे हैं आशिर? ओके, आ जाओ. So this is a very simple question, type 1 question. Okay, so what you have to do is the steps, okay, or the method, if you write step. Okay, so first, okay, okay, so first you have to do is separate d dy and dx, okay, and the variables, right? um dy and dx should be in the numerator. Okay, numerator. This is the first step that you have to do, right? Separate the variable, separate dy by dx, dy and dx and the variables. Okay, so dy with all of the y, okay, and dx with all of the x, and make sure that dy and dx should be in the numerator, right? Now the second thing is, um, integrate integrate both sides. Okay, this is the second step. Okay, now the third step, if the limits are given, then use it. Generally, for this differential equation, we don't they don't give you the limits, they give you the two values of x and y, and you have to find out the constant. Okay, so put the constant, okay, at any one side of the equation and find its value using the given data, right? So, and then you have to give the answer in the required form. That is like the three steps that you have to do, right? Okay. Now let's try another question. So, uh, 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 okay. Fine. So I have this question. Let's try it. Okay. So the question says that, next second, copy and paste. Okay. So this is the question, and the question says that express this in partial fraction, right? So, and this is basically the integration or differential equation related with the partial fraction. Okay. So, you know that if I have, part one, if I have 1 over 4 minus y squared, right? So I can write this as 1 over 2 square minus y square, and I can apply, or I can rewrite this as 1 over 2 minus y and 2 plus y, right? And now I can make the differential equation, that is a over 2 minus y, okay, plus b over 2 plus y, right? And after that what you have to do is just take the LCM and solve. So 1 on the other side, and a times 2 plus y and b times 2 minus y, right? And just take the 2 value, okay? So take 1 y as 2, okay? And when you put y 2, so b gets 0, right? And a will be 1 over 4, right? 1 over 4, right? And when you take y as negative 2, then a would be 0 and b would be 1 over 4. 1 over 4, okay? And this is like the differential equation that you just set up, okay? With a being 1 over 4 and b being 1 over 4, right? So, yes, this is the first part done. Okay. Now let's try the second part. Mm, mm, mm. Yep, perfect. So yeah, now they're saying the variable x and y satisfy the differential equation. Okay, so they just mentioned the differential equation and they ask you to solve it. Okay, and they also mentioned the 2 points x and y and solve the differential equation, obtain y in term of x. Very simple. Okay, now if you have the second part, so x dy over dx, okay, is equals to 4 minus y. So 4 minus y squared, right? Now what you have to do is you first have to separate the variable, right? Y should be on the y, and x should be on the x side, right? So I would do y divided by 4 minus y, okay, is equals to dx divided by x, right? So the variables are separated. Now you have to do the integration. Okay, so let's do the integration. But before that, we know that 1 over 4y squared is or can be written as this thing, right? Can be written as this thing. So basically we have to integrate this. Okay, we have to integrate this with respect to dy. Okay, and that is the integration with respect to dx, right? Now let's try. Okay, so can you guys tell me the integration for this one and that one? Yes, what would it be? Yes, anybody? If you have negative y here, and you can see that the derivative of the denominator is present up there, which is just 1, but we want the negative sign as well, so you can multiply the negative sign as well, and this become 1 over 4. Okay, that's a constant, you don't have to integrate it, so the rest of the thing will be 2 minus y, and there will be negative sign. Okay, and then plus we have to do the similar thing with that, but you don't have to put any negative sign because we don't have any with y in the denominator. So 1 over 4 ln and 2 plus y. Okay, and is equals to over there 1 over x would just be ln x. Okay, and just put c. Okay, this is the integration done. Now you have the data given x y1 and x1, just put that in and find out the c. And okay, so if I put 1 over 4 ln 1, okay, like y is 1, so 2 minus 1, 1, and this becomes 0, okay, and then plus 1 over 4 ln 3, right, and ln, the x is also 1, I think, x is also 1, so 1 ln would be 0, or is 0, so plus c, so I have left with 1 over 4 ln 3, this is my c. Okay, now rearrange the equation. Actually, they're saying obtain any expression for obtain an expression for y in term of x. Okay, so you have to make y the subject. Okay, you have to okay, fine. Let's try to make y the subject. Okay, that's the difficult part. Okay, so now you can say 1 over 4. I can take, I'm taking it into the power. So that is negative ln 2 minus y, and I have the power 1 over 4. Okay, or Can also shift it to the other side as well, but fine, not shifting. Plus ln 2 plus y to the power 1 over 4, okay, is equals to ln x plus 1 over 4 ln 3, right? Now, if you take them common, so this will be okay, since I have to make y the subject, so I have to remove the power as well. Okay, so okay, you can just remove it by squaring 4. So that would just be okay, just don't do this. Instead of that, you can shift 4 to the other side, okay? That will be very helpful. So take 4 here, okay? Take 4 here and the 4 will be removed from this side, right? And solve. Okay. So I would have 2 plus y divided by 2 minus y. And that would be with ln is equals to ln x to the fourth power plus ln 3. Okay. Now I have to remove my ln and it would just be ln 2 plus y and then 2 minus y is equals to 3x to the fourth power and ln, right? Since the two ln's are in addition, so you can take ln common by and you can multiply these two things, right? Now, ln and ln can be cancelled out, right? So we are left with 2 plus y and 2 minus y is equals to 3x to the fourth power, right? Now you have to make y the subject, okay? So what you have to do is 2 plus y is equals to 3 to the 6x power 4 minus 3x to the fourth power and y, and now take it to the other side, y plus 3x to the fourth power and y, and 6x to the fourth power minus 2, and we have take y common, okay, and you'll be left with 1 plus 3x to the fourth power, right, and 6x to the fourth power minus 2, and now it would be 6x to the fourth power minus 2, or you can take 2 common divided by 1 plus 3x to the fourth power, right? So the final form of this is the final form of the solution. Okay, so guys understand? समझ में आया ऊपर से क्या कुछ?
Sir, I have some doubts.
Sorry, no doubt.
Uh, it's like a bit up, like in the previous slide.
क्या कह रहे हो समझ में नहीं आया. I am not getting what you are saying.
Uh, it's like the last thing you did on this page, the 4 ln x plus ln 3.
This one?
You're multiplying everything by 4, right?
Basically, yes. So like
So
from
shouldn't it be
hmm,
4 ln 3?
4 ln 3, 4 ln. Basically, there is the C is basically 1 over 4 ln 3, right? So when you multiply, so this was 1 over 4, right? And when you multiply with 4, so it get cancelled out, right? So this is
Oh, okay.
1 over 4 and 4, right? So this 4 and this 4 get cancelled out, right? Clear?
Okay. And with
Hmm.
the integration, it's like there's like some box method I'm following, but like how does the box method work here? Like The differentiation of the box should be the same thing as the numerator, right?
Yes, so over here it also works, right? If you have like over here, what we say is if you are doing the differential integration of ln, so what you have to do is if you have like for ln function, if you have 1 over the box, okay, if you have like the equation and that equation contain 1 over some variable, okay, and the derivative of that variable is also present in the numerator, then you can integrate it, right? This is what the box method says, right? Now over here, if you look at here, so this is what our box is, right? Which is basically 4 to the 8 minus 4y, right? Or you can take out the 4, right? It's not required in the integration, right? So basically, just ignore this 4 and this is like outside, okay? So this is my box, okay? And I want the derivative of this box to be in the numerator, right? And the derivative of this box is going to be just negative 1, right? We have 1 here, but we want the negative 1. So I multiply and divide the negative 1 with, okay, and then you can integrate it, right? Clear? And over here,
Yeah.
you can also apply the same thing, right? Shall
Okay.
we shall we do one more question or stop here? Yes. What do you guys say?
I think we can do one more question.
Okay. Let me find. Take. Okay. That's the easy one. So yeah. Differential equation. Okay. What happens when t become large? Okay. T become large. Okay. I have this question. Okay. So copy and paste. Okay. So this is another type of question. Or another question of the same type, but a bit different. Okay. So let's try this one. ये कर लो and then इस type के सब हो जाएंगे, right? And then in tomorrow's class we'll do the next two type. Okay. And guys, please make sure to be in the class. Okay. Otherwise, it would be your like it would be problematic for you. Okay, now they're saying in the question, they're saying the number of the insects in the now this is the physical scenario, right? And uh, of that physical scenario, this is the mathematical equation they mention. Okay, sometime they mention this whole setup, but they didn't mention the equation, and you have to and they ask you to come up with the equation, right? So that is the second type of question, and the third type is where they tell you everything, but they don't uh, uh, tell you this thing or these sort of thing, right? And you have to make these relation yourself and then equation yourself, right? So now the number of the insects in the population t week after the start of the observation is denoted by n. Okay, the population is decreasing at the rate of the at the rate proportional to this. Okay, now they're saying rate proportional to this, and after that they also mention the equation or okay, you're asking us to mm, form the equation. This is basically the second type of question. Okay, fine, कर लेते हैं, कोई मसला नहीं है. So they're saying proportion. Okay, so the proportion. Okay, so before that, just understand two to three things, and then we'll jump on to the question. Okay, if they say that something is proportional to some other thing, then what you have to do is you can just do like if y is proportional to x. So what you do is you just do y is proportional to x, right? And then when you remove the proportionality with equality, so you do y is equals to kx, right? This is the first thing that you guys learn in your in your O levels, right? This is the first concept, right? Now if they're saying the rate of, now the other type of saying is rate of change of y is proportional to x, right? This is the second type of like the word problem thing. Okay, so what you have to do is the rate of change of y would be dy over dt, right? Is proportional to x, right? And when you remove the proportionality, you will get dy over dt is equals to k times x, right? This is the second easy thing, right? Now the third thing is, if they mention in the similar question, if they mention that the rate of increase is proportional to x, then again everything will be the same. Okay, if instead of change they're saying the rate of increase of y is proportional to x, everything will be same, right? But if they're saying the rate of decrease in y is proportional to x, right? If they're saying that the rate of decrease in y, okay, is proportional, then you have to put the negative sign over here, right? To show that this is the rate of decrease, right? Clear? So if y is proportional to x, then it would just be y directly proportional to x. But if the rate is involved with any of the variable, then you have to put dy over dt. Or if it is with other variable, then you have to put the dx over dt, or like whatever you have, right? Now this is the second thing. Now the third thing is, if they're saying increase, then increase, for increase you have to show, or you have to put it the positive sign basically with y, or it's fine if you don't, because we generally consider nothing as a positive sign, right? But if you have the decrease in rate of decrease in y, then you have to put the negative sign to show the decrease, right? This is the second type of question where they mention everything. Okay, they mention the scenario, they mention the part of the equation, and they ask you to show the equation, right? So even if you are unable to show the equation, so the equation is itself is still mentioned in the question. So if you are unable to show the first part, just go directly onto the second part. Okay, generally second part is like too much mark. Okay, and the first part where they ask you to show that is like only for 1 or 2 mark, right? So yeah. Now so that is, I'm taking it here. Okay, and that is basically the second type. Okay, second type of question. Wait. Type 2. I mean, differential equation. Okay. So this is the concept you have. Now let's do the question. Mhm. Okay. Now the question says that the The number of the insects in the population T week after the start of the observation is denoted by N. Okay. The population is decreasing at the rate proportional to this. Okay. Okay. So when I the population, okay, the population is denoted by N, by the way. Okay. So the population is decreasing at the rate proportional to this, which mean dn dn over dt, right? Because why dn over dt? Because the population is decreasing at the rate of, right? So rate of decrease in the population is what they're talking about. Okay, is proportional to or proportional with e to the power minus 0.02 t, right? Now, the variable n and t are treated as the continuous, okay? And it is given that when t is this, it is that, and dn over dt is negative 100, okay? Fine. Chalo bhai. Okay. Now, when you set up the equation, okay, tn, this is like the values given. You can put it to find out the to find out any unknown value, right? And now just remove the proportionality and change it with the equality. So it will be just k n e power minus 0.02 t, right? So, and they're saying that dn over dt is negative 10, okay? So dn over dt, acha, we also have to put the, okay, the negative sign, mm, 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 negative 10, okay? So if you compare, you will get, um, acha ji, that is, shit. The population is decreasing at the rate proportional to that.
So it's minus K and E, right?
Minus, yes, over here, right?
I Yeah, I solved this question. I got this exact equation.
Okay, so that is negative k and e and 0.02. But I'm just uh finding one more thing. The population is decreasing at the rate. Okay, this the variable and t and this. Okay, n is there. K is also there. What would be the value of k? T would be 0 and fine negative 10. So this whole thing would be equal to negative 10. So, okay, k
It'll
would
just
be just
be
zero
e
point
to the
0.0. Huh?
1 to e to the power minus 0.02 into 0 be 1.
Let's see. Basically, what we have to do is just negative k and e negative 0.02 t is equals to negative 10. Okay, you can cancel them out, and you have to do, okay, just put time equals to 0, so you will get that. Mm, that would give you 1. Okay, and K would just be K would then be 0.01, right? And
Yes.
to put that back into the equation, you will get dn over dt is equals to negative 0.01 uh, e negative 0.02 t and then n, right? Correct? So this is the
Uh,
equation.
I just wrote
Mm.
as minus 0.01 NE.
No, no problem. It's in the multiplication, so it could be uh, like both the ways are possible, right? Now, this is what we have shown. Okay, and now if you go to now the second part is saying that solve the differential equation, and okay, so when you solve, you first have to separate the variables. Okay, so take n there and 0.01 e to the power 0.02 t with a negative sign, and we have dt and the integration symbol, and this would just be ln n, and it would be negative 0.01 e to the power minus 0.02 t divided by 0.02 and plus c, right? Now the question says that, okay, so when I come, acha, fine. Basically, I didn't show one step here. When you equate them, so k is k would be this one, n would be 1000. Okay, e to the power minus 0.02 and t would be 0, right? And then, come on, what you got? Perfect. Now that's fine. Okay, so actually, if I simplify that, so I would get okay. So to simplify that, I'll get ln n, and that would be just 0.5. So 0.5 e to the power minus 0.02 t and plus c. Now, to find the value of c, I can use n and the t value again. So n in 1000, and that would be 0.5, because when you put 0 there, so e to the 0 would be 1. So divided by 0.5 is equals to c. So c would be 2 ln 1000, right? This is my c, and if I put that back into the equation, so I'll get ln n, right, and is equals to 0.5 e to the power minus 0.2 t and plus 2 ln 1000, right? So this is my equation, right? Now, solve the differential equation and find the value of t when n is 800, right? So you have to find out the value of t when n is 800, So, okay, just put in 800 and solve. And then 800 is equals to, or 800 minus 2 ln 1000, and then divided by 0.05, 0.5 is, and then apply ln both side. Okay, and it will be 0.02 e, so just do 1 over 0.02 with a negative sign, and that will be your t. So t is getting as, okay, if you put 1 over zero point zero 0.02 into ln, and everything inside ln 800 minus 2 ln 1000 divided by zero point 0.5, why it is, so basically when I put 0 that would be 1, yes, zero point 0.5, but they are getting ln n 0 0.5 and y. I'm getting the maths error. Wait, between the equation is incorrect. So 0 0.5 e to the power negative 2, that's correct. To find out the c,
So why is it 1 over minus
oh,
0.02?
sorry. One, what? 1 over?
Minus, you're just going to bring, you're not integrating it or anything. So it
No,
shouldn't, it should just be,
uh, I apply the ln, okay, to remove the exponent, okay, and then when I remove the exponent, so that become the base, okay, so it would just be 0.02 times t, with a negative 2 is equals to this whole thing. So I just divided to make t the subject, no?
oh, okay.
So when you put 0 here, so you'll get 0, and e to the 0 would be 1. Wait. So that should not be in the division. It should rather be 0 0.5 here. Mm, minus 0 0.5. This is how I have to write, right? So this is my C, not that. It should be negative 0 0.5 instead, right? And sorry, and when I move it to the other side, now let me try again. Okay, so when I take it to the other side, so ln 800 right? And minus ln 100, right? ln 1000, right? And plus 0.5, okay, is equals to 0.5 e to the power minus 0.02 t, right? So putting it into the calculator, so ln 800 minus ln 100 ln 1000, right, plus zero point 0.5. So okay, answer divided by zero point 0.5, and ln answer, then answer divided by 0.2 with a negative sign. So I'm getting 29.5. Yes. Okay. So I just made the mistake there. Okay. So just divide that by zero point 0.5. Okay. And this 0.5 gone. And then apply ln here. Apply ln here. And that ln will be gone. The exponent with the e, or the exponent basically goes off. Come on, and you have to do is 1 over 0.02 with a negative sign. Clear? So this is what you have to do. Okay, and then you are basically, this is your t. So t is coming as 29.5. Okay, last part. Okay, okay. Now the last part is saying that state what happened to the value of n as t become large. Generally, when they say t become large or anything become large, so we consider it as infinity, right? And uh, and we know that 1 over infinity is also 0, right? So these are the two things that you have to know, or that you need to know when solving or answering this type of like the last parts, right? So if anything become too large, so that would be infinity, right? And if anything become too small, so that would be negligible, right? Like 0. So you can just put it 0 there, right? So the equation that I'm getting is this equation. Okay. And for the last part, so by the way, solve the differential equation, find the value of t. Okay, state what happened to and it become t become large. Okay, so they're saying t become infinite. Okay. Now, if you look at this equation, so only this factor contain, or only this term contain t. Okay, if I write the equation as L ln n is equals to 0.5, and then in the denominator e to the power 0.02 t, right? So it doesn't affect my equation, right? ln 1000 minus 0.5, right? Now if I put infinity here, so this whole thing become infinity, right? If you add something into the infinity, so that will still be infinity. If you subtract something with infinity, so it will still be infinity. If you multiply something with infinity, it will still be infinity. If you raise infinity to some power, or some power to the infinity, then it will still be infinity, right? So anything, any operation with the infinity leads you to the infinity, right? Now over here, this whole thing, become infinite, right? Because we are doing the operation with the infinity, right? So any operation with, and over here operation mean the mathematical operation, addition, subtraction, multiplication, division, squaring, root, and everything, right? So any operation with infinity leads to the infinity, right? So this is the rule. Okay, so since this term is infinity, and this become ln n and 0.5. So this whole thing become infinity, right? And then the rest remains the same, right? And 1 over infinity is 0, right? So this whole thing becomes 0, or this whole thing turns out to be 0, right? So we will be left with, when t becomes so large, the value of n would be ln 1000 minus 0.5, or you can take the exponent of that. Okay, so take the exponential, so it would be e to the power ln 1000, right, minus 0.5. Okay, so this is what will happen with the t, right? Is that clear? Yes. So this will be the result. Okay, so this is how you have to solve the second type of the question. Okay, where they mention the whole scenario, and you just need to come up with the equation. If they mention any unknown, so you have to solve for that, and you will get the equation, and then you have to move on to the further solution. Okay, so yep, now I'm stopping the class here. In tomorrow's class we'll be doing the third type of the thing, and then it will be done, like the whole chapter will be completed. Okay, then we'll move on to the one more thing, and that is basically the iteration. Okay, it's a very simple chapter, but for the, in its first part they generally give the differentiation or integration sort of thing, but we don't have to do that because we are basically looking at the iteration, right? So yes, okay, fine, so I'm stopping here. Okay, so till then, take care. Allah Hafiz.
Gracias.
Hafiz.